All right, we've made it. We are officially at the last video for all of our grouping techniques our factoring techniques in this particular unit. Unfortunately, like I've mentioned before, we are going to get a couple more factoring techniques, but not until later in our class when we look at another kind of polynomial that we haven't really talked about yet. But for this particular unit, we're wrapping it up right here. And in this video, what we're going to do is we're going to look at how to factor a difference of squares using grouping, which has been our primary method for factoring everything. Remember, the nice thing with grouping is that grouping always works for any sort of quadratic equation that can be factored. Okay, so that's what we're going to get into right now. Hopefully, if you're interested in it, you already watched the video on using the shortcut to multiply and to factor. Now we're back to using the full method of grouping. And the trick to this was we have to introduce a middle term. So with that said, let's get started by talking about how to do this process. Okay, so we've already talked about how to do both of these things with the shortcut. And in the original video where we talked about why the shortcuts work, we multiplied conjugate pairs using distribution like usual. In this video, we're just going to skip to factoring a difference of squares utilizing grouping. So we're going to start with one where the numbers are nice and small and convenient so that we can focus on the process and not get overwhelmed by the numbers we're dealing with. So let's factor a 4x squared minus 1. Okay, so whether that you recognize that this is a difference of squares or not, if we're using grouping, that doesn't matter. If you want to use the shortcut, then you need to know that this is a difference of squares. But for grouping, we don't care. The first thing that we want to do when we're grouping is we want to uncombine the middle terms, right? We've talked about this all along. When I multiply two binomials together, I end up with two x terms that have to combine. So the first thing we want to do is uncombine them. But the challenge is I don't see any x's. I've got some x squareds. In fact, I have 4x squareds altogether, but just plain old x's, I don't have any. So this is where we go back and we take advantage of the fact that there's a symbol for having nothing in math, and the symbol for nothing is the 0. So we'd say that we have 0 x's. We just add that into the middle of our problem. And now we can go through the uncombining process that we've talked about in several different videos at this point. I'm going to begin by multiplying the 4 and the 1 together. And then I'm going to take that answer and I'm going to find all the factor pairs that multiply to equal that answer. So all the factor pairs of 4, well, there's 1 times 4 and there's 2 times 2, and that's it. Okay. Now I need to subtract to equal 0. Okay. So I need to find the factor pairs that subtract to equal 0. Well, these are the only ones that will do that. It's got to be 2 and 2. So the next step then is I write down that I've got to have a positive 2 minus 2 if I want to end up with 0. And remember, you can always double check that because these two things together should have the exact same value as our middle term, which in this case is equal to 0. Okay, so now that I've done that, I'm going to finish the problem by moving into the grouping process. So first we uncombine, and then we use grouping. Now that we've got 4 terms, we can go with grouping. So in my first group, I want to find the greatest common factor. So the greatest common factor between 2 and 4 is a 2. And the greatest common factor between x squared and x is an x. So my first group is going to factor with a 2x. And then 2x times what equals 4x squared? Well, 2x times 2x equals 4x squared. And 2x times what equals 2x? Well, 2x times 1 equals 2x. So there's my first piece. In this piece, I know that they have to match, so I can just copy that down, and then I can divide. A -1 divided by a +1, that equals -1, so that must have been what I factored out. I can check that. Does -1 times 2x equal -2x? Yes, it does. So now this group is also done. For my final answer, I take the piece they have in common, and I write down some parentheses with the leftover stuff, because that must have been what this distributed to make that middle answer. So there's my answer. Okay. Definitely a longer process than using the shortcut, but at least it's a familiar process. And the nice thing is, since we want the middle to equal 0, we can be pretty certain that the two numbers that are going to go right here are always going to match each other, right? Because what other kind of numbers will subtract equal 0? Only ones that match each other. So that's maybe a helpful hint that we can use for finding our answers. All right, let's do one more. Example number 2. Now, with this example, I'm going to go ahead and let things get a little bit ugly. We've done an example where we could focus on the process because the numbers were nice. This time, we're going to talk about the downside of using grouping. The downside is sometimes the numbers get ugly. So let's go ahead and let that happen. So I'm going to say, 25x squared minus 36. Okay, now for those of you who are comfortable with the shortcut, right now, this is a pretty easy problem. You can get to the answer relatively fast. But the purpose of this video is to talk about what we would do without the shortcut. So first, we have to uncombine the middle term. What is the middle term? It's a 0x. So I would write in the 0x, and then I would go through the process of uncombining the 0x. So that means I need to do a 9 times 36. Well, these are some big numbers. So let's see, what do we get? A 9, I'm sorry, where did I get 9? 25. How did I get 9? I don't know. 25 times 36. 900 is what we get. 25 times 36. So this is the downside of using this method, is that we end up with big numbers. And now we have to find all the factor pairs of 900. Well, I'm not sure what they all are, but I'm sure there's a boatload of them. So what I'm going to do is the old trick that I've shown you a couple of different times. I'm going to switch over and utilize Wolfram Alpha to help me find what those are. So let me share my screen with you and talk about what are we getting here. So here I am. I've just gone to wolframalpha.com. and I need the factor pairs of 900. So remember, we can just type this in like a question. One of my students discovered today that this word pairs is important. Don't lose that word. Make sure you're asking for factor pairs and not just factors. So there we go. We're going to find the factor pairs of 900, and here they are. So there's a bunch of them. There were 14 of them all together. So I'm glad I'm not trying to do this by hand. So specifically, what I need is, looking back at the problem on my paper, what I need is I need the ones that subtract to equal 0, subtract to equal 0. So that means there have to be two that match if I'm going to equal 0. And right here they are. There's a 30 times 30. So 30 times 30 must be the pair that I want. So let's get back to our paper. If I want to subtract to equal 0, then I need to use a 30 times a 30. And that's going to be the way I break up my 0. 30x minus 30x. Now I drop down all the other pieces. Minus 36, positive 25x squared. And that takes care of my first step. I've uncombined. And I've done it even using ugly numbers. All right, so now I move on to my second step, which is grouping. Again, I've got some bigger numbers. Maybe these are numbers that you can do in your head, maybe not. But if you're not sure what the greatest common factor is between 25 and 30, we can always go back to Wolfram Alpha. In fact, since I have it open right now, I'm just going to go back to it anyway. So even though maybe we can do this in our head, what is the greatest common factor, GCF, of 25 and 30? And the greatest common factor is a 5. Okay, so remember, we can do these things right in Wolfram Alpha to help us if these are numbers that are too big or that you're not certain about. So the greatest common factor of 25 and 30 we just found was a 5. For my x's, my greatest common factor is going to be an x. And then from here, I can just figure out the rest. So 5x times 5x gives me a 25x squared. So that's what's going to go in my first spot. Got a plus sign in the middle. And then 5 times 6 is equal to 30. And I already have my x's, so that's going to be good. Over here, 5x plus 6 is got to be my parentheses. To figure out what number I factored out or what number needs to be distributed, I can just divide these. Negative 36 divided by positive 6, well, that equals a negative 6. And so I end up making my two parentheses. In the first set of parentheses, there's the part that they have in common because I'm factoring that out. And in the second parentheses, there's the bits that are different because that represents the stuff that I distributed to. And so there's my final answer, right? So that's our last video for factoring in this unit. Hopefully that helps you a little bit. As always, if you've got problems, concerns, questions, let me know and I'll try and help. But that's the end of this video. Thanks for watching.